12. There was a lot because I think they were asking all 6 trig functions. Is that right? I think they were asking all 6 trig functions. So if you guys notice, there are times. Can I zoom in anymore? There we go. Okay, there are times when just setting up the triangle, you will naturally get like an opposite over hypotenuse or an adjacent over hypotenuse of 1 over rad 5. But remember, they're just rationalizing to go from that form to this form by multiplying by rad 5 over 5. Sorry, rad 5 over rad 5. So there's that whole rationalization thing above. But otherwise, you're just using the triangle. Wait a minute, where on earth did rad 5 come from? It wasn't there to begin with. Pythagorean theorem, 1 squared plus 2 squared square rooted, that's the hypotenuse. And remember, I think these are the ones where they're giving you the points, like the x and the y. So anyway, there's all 6. Sine, cosine, tangents, and then you flip them. And if you guys notice, it's a lot easier to flip from the non-simplified form than to flip from the simplified form. But to be honest, it might have even been easier to just think about cosine, where cosecant is hypotenuse over opposite, sorry, and secant is hypotenuse over adjacent, etc., etc., etc. So, did the change work out?
Yeah.
And technically, you're allowed to. It's just $1.
Oh, it's only $1?
There you go. Go, Steve. Okay, so moving on. Oh, sorry, the whole point of this one was whether it's a little triangle or a big triangle, as long as the sides are, look, 3 over 6, 1 over 2, as long as the sides are proportional, guys, the ratios end up being the same thing. Because similar triangles, the sides are proportional, and this is just kind of showing you guys the trig. It's not about how big the triangle is, it's all about the ratios of the sides. So small or big, ratios are the same. Okay, sorry, number 24. You were converting? Maybe you were converting if your head thinks in degrees rather than radians. Maybe you went to 60 degrees and then thought about your triangle, or maybe pi over 3 you were able to get to the right spot to begin with, and then you pulled out your tangent is your truth. Number 38, did you guys go figure out where those minutes and seconds were in your calculator again? And or did you use fractions? Oh wait, that's not supposed to be equals, that's supposed to be a plus. It's not supposed to be equal, it's supposed to be a plus. Or you could have converted 8 over 60 is how many minutes per degree, and 10 over 3600 is how many seconds per degree. So you could have gone that way, or you could have used the 3-step feature. Pre-cal today. We talked about degrees, minutes, seconds for the first time. As we did that, I pulled up the calculator and I showed them where I showed you guys with the second apps menu where these little guys are. Well, he's above the plus sign, right? The alpha plus. And ironically, when we plugged it into the actual features in the calculator, the answer was a little bit off. And the reason is, if it doesn't work perfectly, if these are repeating decimals, I think the programming for these little tick marks rounds it and then adds it, and it introduces a little bit of error. So it's possible if you're using the program in the calculator, your decimals might be a little bit different, which kind of stinks. So I wish they didn't round it in the program. So anyway, plugging in secant, remember secant is 1 over cosine, and that's how you would have to plug it into your calculator. So 1 divided by cosine of, and then just cosine of for that. These guys were the ones where it was 54. You were trying to make it match. So the way to make it match was to look at the other side and say, he doesn't have cosine squared. Oh wait, cosine squared can be a rearrangement of one of those properties. I can plug it in and simplify. Kind of had to be strategic on that one. And that cosine squared substitution, this two, remember, came from a rearrangement of sine squared theta plus cosine squared theta is 1. So like I was showing you, you can rearrange them. So then they made that substitution. And that's how they plugged that in. then last but not least, number 70, I think it was one of those word problems, those practical, like, use trig to solve problems. They gave you an opposite and an adjacent. That was unknown, this was known, and so if you threw in the angle, you were able to solve. Okay, did we get stuck anywhere that we need to ask about? Bianca.
45C.
45C. Anything else besides 45C? We're good? Okay. 45 was one of those use the clue to solve for the unknown. Use the clue to solve for the unknown. So, cotangent. You can either think of him as the reciprocal of tangent. You can take this. He doesn't have a denominator, so I make one. And from this, if you know he's the reciprocal of tangent, you can take tangent of alpha, right? Greek alphabet. You could make tangent 1/5 if that works better in your head, or you could go ahead and think of HPrecalc. It's like HPrecalc but flipped. And HPrecalc, cal stands for cotangent of an angle is adjacent over opposite. So either way, 5/1 is adjacent over opposite, or 1/5 is opposite over adjacent. Either way you fill in for your alpha triangle. A 5 needs to go in the adjacent spot, or 1 in the opposite spot. And how do we solve for this other guy? Just in case we need the hypotenuse? Yeah. So that'd be 5 squared plus 1 squared is 25 plus 1, 26. Good? Okay. So when we go to solve, oh, hey, I already have one. He's the reciprocal of cotangent. Cosecant. That's 1/sine, right? So it's opposite over hypotenuse flipped, or it's cho for HPrecalc. And cho would be cosecant of theta is hypotenuse. However you think about it, taking sine and flipping them, or cosecant is just hypotenuse over opposite. Hypotenuse we just solved. Opposite is 1. I'm just doing all of them. Cosine. Oh, so adjacent over hypotenuse, so 5. But guys, you know they wouldn't stop here. What would they have done next? Yeah, rationalizes this snazzy. And it kind of ends up with this guy being on top. Like, I get what you're saying, but careful. And then this is the one you were stuck on, yeah? This comes back to that whole complementary function idea, the co-function thing. Because cotangent is the complementary, look, 90 minus, it has to do with the complementary angle. Cotangent is complementary to tangent. So the nice thing is cotangent of the complement is tangent of the original. These are the exact same thing. And the nice thing is we actually had in our notes, oh, I need to go find it. I think I wrote down a little page of notes. What did I write down? Co-function. And then we talked about it. Yeah, right? Oh, and I just lost all that. Oh, that's it. Co-function. Yes, here it is, complementary. Tangent is the same thing as cotangent of 90 minus. So, a function of a complement is the same thing as his co-functions. Well, cotangent's the co of, or the co-function of tangent's ratio of the original. So, with that, I was able to say, oh, hey, you're the same thing as you, and you are, I already know one of them. Like, in a way, it's a formula to memorize, but in a way, it's an idea too. So, he's probably one that high school me would have just memorized. But adult me would probably be like, oh, if I can understand it, I don't have to memorize it. Okay, any other homework questions we found besides 45? Okay, let's go play with finishing up our 4.4 notes then. Because in some ways we didn't get very far yesterday, but in some ways I kind of mentioned. Oh, so you guys didn't have questions on either of those.
If you guys want, I did this one yesterday with you as far as like you have a point, you can make a triangle. You don't have to make a unit circle. Emily was like, hey, let's just scale it back to being the unit circle. And I'm like, we can divide everything by 5, or we could just say opposite, hypotenuse, adjacent, SOHCAHTOA. But we were just starting to talk about reference angles and how, okay, we're going to be landing with these thetas in different quadrants, like quadrant 2 or quadrant 3 or quadrant 4. And if I'm having you guys use triangles, you have to know what triangle to draw. And so we're drawing a triangle for what's called a reference angle. And if we can draw the triangle for the reference angle, well, then we can solve. Like this one. The angle ended up being, I don't know, 120 something, 130 something. The angle ended up being some angle that could not possibly be in, well, I guess it could be in a triangle. But 120 can't be in a right triangle. So instead of trying to make a right triangle, which is impossible from the big angle, instead we say, well, let's use his reference angle, and his reference angle would be this little guy that brings him to 180. So that reference angle, if I was to talk about him, or if the book was to ask me what he was, the reference angle is the angle whose triangle I get to use for that bigger angle. So he would just be 180 minus. Now, in this example, they didn't give us theta, so they wouldn't ask for the reference angle because we didn't need to know him. We just needed to know the ratios. Okay. But in other problems, they will give us angles and they will ask us for the reference angle just to make sure we're looking at the correct right triangle. There you go. Because if we're looking at the wrong one, all the ratios are going to be flipped, are going to be wrong, and then we're going to be all mixed up. So let's go talk about these reference angles. If you're talking about a reference angle is always I would highlight, he's always a little baby acute angle. He has to be less than 90 to be in a right triangle. He's always an acute angle. And the reason why he's always acute is because he has to be the positive angle in the right triangle used for SOHCAHTOA or HPrecalc. So the reason why this reference guy is important is just he's the guy whose right triangle we're going to be using for the other angles, sine and cosine and tangent and cosecant and secant and cotangent. But once again, guys, I covered the unit circle with triangles, so in some ways you've been doing this already without really giving it a name. We twist the theta, we end up somewhere that we can't draw a right triangle with theta, we draw a right triangle on the other side of theta. And then we use that opposite, that adjacent, that hypotenuse for that angle.
You know, quick question.
Yeah.
So that night, robotics order and t-shirts, we were wondering if you bought one.
No, let's make the check.
Okay.
Just a minute.
It's like $16.
Come whenever, I'll get you a check. Well, that's fun. Go robotics. Although they're in my calculus class, and we haven't made specials yet.
What about pre-calc, honors pre-calc?
I knew that was going to come up after I said it. Well, you guys are definitely fighting for it. If somebody emails me a design that I could send in textures that doesn't have anything questionable regarding your attitude to math or the school or any moral issue that you guys obviously knew or know shouldn't be on there, I will submit it and give
get a price quote on it, and it'll let you get t-shirts and no sweatshirts. but t-shirts.
Oh.
But we'll have to see what the price quote is on it because we're going to be small class.
Yeah.
But hey, maybe you guys getting a T-shirt is what's going to take what it's going to take for the calculus classes to actually get their act together.
What is that?
She's on it. She heard me.
What's the positive of making them green?
Angle. In geometry, sometimes we use that to be like an angle mark. Kind of like this is perpendicular. Okay, so if I was to give you, for instance, like an example in the second quadrant, let's do something super random, like, I don't know, theta is equal to 137. Okay? It's bigger than 90. It can't be in a right triangle, but it can have a right triangle attached to it. Like this one, a right triangle that is relatable to the theta. What would be this guy's reference angle then? How would I find it? Yes, because if he's 137 and he's in the second quadrant, all I need to do is say, hey, what's left? Okay, subtraction. So 180 minus 137 would end up being 43. Mental mathers? So how am I always able to do a reference angle for any angle in the second quadrant? I just do 180, careful, or pi, depends on whether I have radians or degrees, minus my theta. Does that make sense? So whether it's degrees or radians, I just need to subtract from that half circle measurement. What if I'm in the third quadrant? Let me do a radian one this time. What if I say that theta is equal to 7 pi over 12? Ew, gross. Why do you do that? It's not even in the unit circle. That's why I did that. What's 6 pi over 12? Oh, wait. Whoa, I went the wrong way. Yeah, 6 pi over 12 is 1/2. I just went in the second quadrant again. What quadrant am I supposed to be in? Okay, so what if I did 13 pi over 12? Is that better? Because now I'm all 12 and one more, right? Cool. So now I'm in the third quadrant. How am I going to find I'm too big. How do I get back to 180? Yeah, theta is bigger than 180, so I'm going to subtract either 180 or pi. So who am I subtracting in this one since I have radians? Am I subtracting 180 or pi? Yeah, so I'm going to do my 13 pi over 12. Why am I subtracting 12 pi over 12?
That's pi.
Because then I just can do it mental math style and say, oh, that's easy. It's pi over 12. Does that make sense? So if you can visualize like where the angles are, as long as you understand the reference angle just gets to the 180, either angle's too big, so subtract 180, or angle's too small, so subtract from 180. If it's in degrees, radians, just substitute the 180 for the pi. I think visualizing helps. There's just a few of you out there that I know don't really like to visualize or don't visualize. So there are little baby formulas. If you're in the second quadrant, always do this. If you're in the third quadrant, always do this. But I have one more case. What if I'm in the fourth quadrant? Is anybody realizing the first quadrant's missing? Why do I not have a picture for the first quadrant? We'll ask ourselves that next. But let's go back to degrees because they're a little bit easier for us to visualize. What if I was to give you something like 312 degrees? Not 90, not 180, not 270. Okay, somewhere before 360. How do I figure that guy out? Geometrically. How do I figure that guy out? Guys, we're doing good. You're feeling it in. I have 312. He's actually going to be a little bit down here. I can't draw a right triangle with 312. He's way too big, but I can make a right triangle kind of underneath him. What's that angle going to be? Yeah. It changes. It's not 180 anymore. He's over here by the 360 line. So I'm going to do 360, or, ooh, what is that in radians? 2. So here's how to find my reference. Here's how to find my reference. Here's how to find my reference. So 360 minus 312? 48, yeah? Here. So the question I asked a second ago, why don't I draw one of these in the first quadrant? Is it bigger inside the right triangle in the first quadrant? He doesn't actually have a reference angle. He is his own reference angle. So in quadrant 1, I don't have to worry about it. There really is no other reference angle. But in quadrant 2, I have a way. In quadrant 3, I have a way. And in quadrant 4, to do my HPrecalc HPrecalc, even though the angle doesn't fit in the right triangle. To some extent, it's kind of just a natural understanding, and to some extent, there might be, I don't know if it's a need, but it might help to kind of study it. It might help to kind of study it. So if I was to do something like, let's use one of our unit circle values, just because some of you are still trying to get that unit circle down. Let's say I did 5 pi over 3. I wanted, let's just do sine, cosine, tangent. Okay. What quadrant is 5 pi over 3 in? Close. Because this is 3 pi over 3, right? Does that make sense? I have 0, I have 3/3. This would be 2 pi, which would be 6 pi over 3. You see it? It'd be 1/3 away from ending. So, even though my angle is way out here, my 5 pi over 3, maybe you guys realize that we would be looking at the triangle of pi over 3. The reference angle to 5 pi over 3, my alpha is pi over 3, so I get to think about a pi over 3 triangle just in the 4th quadrant. And so what's happening at pi over 3 in the first quadrant happens here too. The only thing that changes is instead of going a positive x and a positive y, I just go a positive x and a negative y. The 4th quadrant changes the signs, but it doesn't change the ratios. I can use the same exact ratios for the reference angle to get the ratios for the bigger angle. So when we say down a lot, that's me. Over a little, that's Emily. And we have our 1. When we do our HPrecalc HPrecalc, we're using pi over 3's triangle just in this weird flipped 4th quadrant location. So my sine is equal to negative root 3 over 2. My cosine is equal to 1/2, and my tangent is equal to opposite over adjacent. But that's also why in our cheater chart we can use that pi over 3 column, because 5 pi over 3 has this guy as a reference angle. So I can use my 1, 2, 3, 3, 2, 1 all over 2, square root of 3 over 3, 1 square root of 3. I know where this guy falls in that progression, so I can just go ahead and, know my sine, know my cosine, know my tangent. Wait, but the signs are different. I know. We get the numbers from the cheater chart, and then we ask ourselves, all students take, who gets to be positive? The cosine dude is going to be positive, everybody else negative. So we've been using reference angles, we just haven't really been talking about them with their proper name. Because we've been saying, it's a pi over 3 angle, just in the 4th quadrant. By saying that, we know the reference angle. It's pi over 3. He's the little guy that fits in the triangle. Kind of, sort of. Maybe. Okay. So with that, let's talk about what this homework's going to have. And to be honest, guys, whoa. We only have 3 pages of notes? I know some of you guys are seeing that quiz. Just hold on. Let's finish up notes.
if they say to solve for trig functions, number 1, find the reference angle. Number 2, set up a triangle with that reference angle. And number 3, solve. So this is why, even though Mr. Che was doing exactly what he was supposed to, and he had you guys fill in that blank circle last year, to be honest, in pre-calc, I don't want you to have the whole circle memorized. I want you to have one quadrant and be able to use it. I want you to have the cheater chart and be able to use it for the rest of the quadrants. Or I want you to be able to use triangles. That's something smaller to memorize, and you can use it to solve for anything you might ever possibly. Not be overwhelmed by 4 quadrants of all this information. So that's kind of the idea of a reference angle. So the other 2 pages, guys, are just examples. They call the reference angle, sorry, I just saw this. They call it theta prime at, I don't know why, just because. I was calling it alpha, just in case you want to tie together the notes. I was calling it alpha, they're calling it theta prime something, something, something. I don't know. But either way. Solve for all your SOHCAHTOA of a bigger angle that doesn't fit in a right triangle. No big deal. There's still a right triangle. Use that in the proper quadrant. Just watch out for your signs. And remember, you're all students. Take calculus. To double check. Okay. So, what if I give you some weird angles that I want you to find the trig of? Oh, never mind. We can try to stump you first with just finding the reference angle. They're not even saying sine or cosine or tangent. They're just saying reference angle. If you guys had your full groups here, I would clearly have you work in groups, but there's only one full group. Everybody else is missing people. So let's just work together as a class. What's your brain telling you to do for letter A when I want the reference angle? 360? Why 360? It's the closest thing. Literally, that's reference angle. You get it? Closest thing. Think about it. Did anybody land here? Right? So if that's 300, the closest thing, the closest axis. Now, some of you, careful, are going to accidentally go here. We never go to the Y. We never go to the vertical. We always go to the horizontal. You want to think about it like in practical terms. We're not going to measure from some random vertical line in the sky. We're going to measure to the ground. Because the ground's way easier to measure to. If you're doing like elevation or something weird. So, always measure to the ground. Where's the ground? There he is. Sweet. Okay. So, what's my reference angle? Okay. 60. So if I need to find sine or cosine of tangent of 300 degrees, I just throw a 60-degree triangle in there and I just think about my positives and negatives. All students take calculus. The cosine and the secant are going to be positive. Everybody else is going to be negative. All students take calculus. Cosine and his reciprocal are positive. Everybody else is negative. We don't like inequalities usually. This one looks easier. B or C? Yeah, I think C too, right? Okay, so land me in the quadrant. We have to figure out where we are to know whether we're going to 180 or 360 or what are we doing?
Going to
Good. So quadrant
3.
Yeah. Is your headland there? Negative, not going up, but going down. 90 and another 45. How did I know it was another 45? I already answered it for you. How did I know it was another 45?
Because the close thing, 180.
Careful. Sophia said 90 plus 45, and she's right this time. The question was this 90 plus 60? It's 90 plus 30. Careful. We always have to, only on 45s is it the same either way. I did it because I thought of 180. Does that make sense? 180 minus you. Negative 135 plus 180, whatever. I just need to figure out 180 minus 135. What's the in between?
It's always supposed to be a little baby acute positive angle. Never negative, always positive. So I could use a 45-degree triangle in the first, second, third quadrant. All students take, and I need to remember that both my tan and my cotan are going to be positive. Everybody else is going to be negative. Okay, so why is letter B hard? Yeah. No degree mark, and if he's not a degree mark, he must be in. So, has anybody figured out what quadrant? And if so, how did you think about it? There are a couple different ways.
First quadrant.
Not first quadrant.
Second quadrant.
Yes, but why? Pi. Pi. Pi's here, right? Pi is a whole half circle. How many, well, what's pi as a number?
44.
You guys know this, right? It doesn't connect. If this is 3.14, where's 2.3? Does that make sense? And if you think about, I don't know if you remember from our notes, but we talked about how one radius of some sort of circle, the radius wrapped around the circle, the flexible ruler, that's 1 radian. So I always think of 1 radian being about 60, and so 2 is somewhere here, like 120-ish, 3 is almost 180-ish, 4 or 5. But anyway, yeah, 3.14 minus a little bit. So it's somewhere here. Do I know exactly where? No. Not unless I convert it, but who wants to convert by multiplying by 180 over pi? That's not a mental math problem to do. So whatever, 2.3, I don't know. He's somewhere over here. So how am I going to get his reference angle? Don't worry, it's not going to be a nice answer. It's going to have like a awkward representation of an answer in there.
3.14 minus 2.3.
Yeah, just do pi. And just leave it. You don't need to know it any better than that. You just say pi minus 2.3. You don't need to simplify it. It's okay. It's what we would have done for supplementary and complementary given in radians. Pi over 2 minus or pi minus. Sorry, not 23, 2.3 because the decimal got lost. There we go. But yeah, just leave it like that. You could put it in your calculator. You could get a decimal if you really want to, but whatever. Just pi minus. Figure out who that little leftover guy is. There's my reference. There's my reference. And there's my reference. Okay, one more set of examples, and then we're done. Okay? So. Oh, where'd it go? There it is. Wait. Isn't this totally what was in section 4.2? Yeah, I thought. And totally what was in section 4.3? And now we're in section 4.4. Do you think this unit circle thing is important? Yeah. Just use what we just did, guys. What quadrant is 4.3? And before we worry about cosine being adjacent over hypotenuse, or the unit circle, just think about your angle. Don't be dumb.
Third.
Because it's 3 over 3 and 1. So even though this huge angle is there, what right triangle could we be thinking about for our SOHCAHTOA? So for those of you that are stuck in that circle from last year in Algebra 2, maybe a triangle is easier. Because you're going left a little bit and down a lot. If you remember your pi over 3 from your cheater chart, 1, 2, 3, 3, 2, 1, all over 2, square root of 3 over 3, 1, square root of 3. Square root of 1 is just 1. And then your cosine, SOHCAHTOA, is 1/2. No, but you're so close. All students take. The reference angle is a pi over 3. It matches up with a pi over 3 whether you're memorizing the circle or whether you're remembering the cheater chart or whether you're just thinking of geometry and the special ratios. Cosine is the one that goes with 1/2, but he's headed negatively. Or only sine gets to be positive. Oh, nope, only tangent gets to be positive in the third quadrant. So cosine is a negative 1/2. But guys, you could have stolen the 1/2 from the pi over 3 column and just been like, oh yeah, cosine is negative in the third quadrant. Dun. What about negative 210? ¿Dónde está? Nope. Why did I trick her? Positive 210 is in the third. But negative 210 is in the. Let's see it. Wait a minute, but 210, who is that guy? I don't know. What's his reference angle? How far from 180 is he? 30. If he's 30, isn't he going to be the guy that goes with the other column in the cheater chart? 1, 2, 3, 3, 2, 1, all over 2, square root of 3 over 3. Tangent. Square root of 3 over 3. Wait a minute, no! Oh, that's right. All students, only sine is positive, which means tangent needs to be. Is that kind of nice?
Kind of.
To be honest, the cheater chart, I only really use it for square root of 3 over 3, 1 square root of 3. Because I don't have the tangents memorized. You have to like do fractions for those, which is kind of gross. So I just know the 30 degrees are the pi over 6s, and they go in this first spot. The pi over 4s are the 45s. They go in this second spot. 1, 2, 3 to 2. 3, 2, 1 to 2. All over 2. Square root is kind of awkward, I know. Square root of 3 over 3. 1 square root of 3. And I know the pi over 3's go in 60s. I know one quadrant, or like the unit circle. I know one quadrant, and I use it for all the rest, thinking of reference angles, basically. I know my pi over 6, I know my pi over 4. I think of it like over a lot, up a little, over middle, up middle, over a little, up a lot. And that's how I think of all of my over a lot, up a little. Over middle, middle, and over a little, up a lot. I actually think of lots and littles when I'm doing all of my different placements in my unit circle. Why? I don't know. It's the way I learned it. But there's one other way to think of it, and I'll show you. It has to do with your hand. Actually, your hand. Your hand. There we go. It was a George Corey thing. Maggie liked it too. I don't know. Maybe you will also. Let me do one more. What quadrant are we?
Fourth.
Ella was right, second. But hold on. Why did I make you guys keep thinking? A lot of you are like, oh, it's big, it's a fourth, it must be down here. But wait, isn't this 7 pi over 4? Because it's a little bit less than 8 pi over 4, but more than 4. Wait a minute. It's beyond this. It's getting over into the, I have 1, 2, 3 calzones, but I'm shy 1. So I went 4, I went 8, I went 12, just kidding, 11. Another way of thinking about it is 1/4, 3/4, 5/4, 7/4, 9/4, 11/4. Or you could think about it as 4 goes into 11, 3, and has 3/4 more. So I have 2 and 3/4. Yikes, I can't divide and do a mixed number all at the same time. 1, 2, and 3/4 more. Good job, Ellen. So here I am at 11 pi over 4. It took forever to get there, but once you get there, it's just a pi over 4. I just need cosecant. Ugh. And I know that all students, the sine ones, are allowed to be positive. Now I know, you have to figure out where it is. Check. You have to figure out what sign it's about to have. Okay, we'll think about that. But then you have to think about cosecant. The trig properties. Who's cosecant? 1 over sine. So I say, it's a pi over 4, 1 over... The pi over 4s aren't fun to flip unless you remember that square root of 2 actually came from 1 over rad 2. Flipping it's nice and neat, kind of like in homework at the very beginning. There were those ugly 1 over root 5 ones that you had to rationalize, but to flip it, it's a lot easier. Does that help everyone? No. Some of you are like, but I have the other one memorized. Can't I just flip this one? You can, but when you flip it, it's going to be kind of yucky because it's going to be 2 over rad 2. He is built on sine, so he's a positive, but you would have to rationalize him. It's a little nicer to know this and just flip it. I don't know. You could also draw the geometry triangle and be like, it's a 45, that's a 1, 1, root 2, and do HPrecalc, hypotenuse over opposite. But you have to remember who's negative, who's positive. Sorry, there are a few different ways. Cosecant or flipping, these guys get gross. Unless you know it just ends up being that guy flipped. Okay, what was my finger trick I was telling some of you? Cheater chart, it's great. Unit circle, it's good. With this reference angle idea, I can take that and use it for everybody. I can take this and use it for everybody. As long as I remember all students take calculus, and I can take an angle and put it into a category of who he's going to match up with. The finger wag is kind of silly and kind of cool. Because if I was to think of, I could trace my hand, it's not going to make a big difference. If I was to trace my hand, I know, I'm just making it somewhat proportional. Could this kind of be like the first quadrant? Right? Where this is my 0 and this is my 30, or my pi over 6, and this is my 45, or my pi over 4. Or this is my 60, or my pi over 3, and this is my 90, or my pi over 2. It's like the cheater chart on your hand. Wait, and how does that help? Like, so far, nothing is telling me that it's a pi over 6 or a pi over 4 or a pi over 3. It doesn't help with that. It helps with your ratios. Ready? When you fold, so let's say I was to want to look at this guy. Ready? If I wanted to look at pi over 6, or 30 degrees, I would fold him in, and when I fold him in, little fingers all the way. When I fold him in, right? Don't you guys see 3 and 1? 3 and 1? Hey, isn't it going to be a over a lot? Square root of 3 over 2, and an up a little, 1/2. These guys could point you to your cosine, and this little guy could point you to your sine. Because you're going to have 3. Hey, my x is root 3 over 2, and my 1 is root 1 over 2. Wait, does that work if I was to fold in my pi over 4? 2 over 2 root 2 over 2. And my pi over 3, 1/2, and root 3 over 2. Wait, what about 90? 0 and root 4 over 2 will give me my 0. What about my 0? Root 4 over 2, which is 1 and 0. It actually works for all of them. Ooh, hey, maybe I can get my cheater chart down on my fingers. I don't know. It's silly, but for Maggie, it was nice to be able to be like, oh, it's a pi over 3. Got it, 1/2 root 3. It's a thing. Anyway, you're welcome. I think I've shown you absolutely every possible way to visualize the unit circle. Here's the dilemma. You guys need to find a way that works for you. Pick it, stay with it, master it. If you have like the big old circle and the chart and the finger thing and that you're going to get confused and all of this. Guys, that homework is due today. The quiz, let's not worry about that right now. Instead, this weekend, choose a unit circle way for you. And can you use it no matter what? Sound good? Okay. Choose a unit circle way for you. Can you use it? Oh, Priyanka, is this yours? Yeah. Okay. I got it. Cross country kids, hope it was a good meet. Talk to you guys later.